welcome back to class. In today's lesson, I want to use this example to further help my viewers understand how to work with energy stored in capacitors. Our question says a parallel plate is charged to 50 microcoulombs. Here's a parallel plate, that is Q on this parallel plate is the same thing as 50 microcoulomb, and at 150 volts, the voltage is at 150 volts, so that V here is equals to 150 volt. It is then connected to a capacitor of capacitance 4 times the capacitance of the first capacitor. That is, this arrangement is scattered. Let me use that word. Then rearranged, and another capacitor is brought in. So that here will be the new arrangement where it is now connected to another capacitor, which is 4 times this capacitance of the first capacitor. That is C2, which is the capacitance of this capacitor, is the same thing as 4C1. Let's keep that first. Let's get back. Now, my question now says, it is then connected to another capacitor of capacitance 4 times the capacitance of the first capacitor. Find the loss of energy. Now, the first thing is, let's find the initial energy that is in this system. So that we have Q now to be equals to 50 microcoulombs, V to be equals to 150 volts. And we know that Q is equals to CV, and also we know that energy E is equals to half CV squared. In case you missed our first lessons on energy stored in a capacitor, please don't hesitate to check the description below. We've done an introductory lesson to this course. So that if Q is equals to CV, obviously C now will be the same thing as Q over C. So my Q in this combination is the same thing as 15 divided by 150 times 10 raised to power minus 6. Now, so that my C now will be the same thing as 1 over 3 times 10 raised to power minus 6 farad. Now, let's keep this. If C is equals to 1 over 3 times 10 raised to power minus 6, then we can solve for the energy in the combination. So that the energy in this circuit, E, will be the same thing as half times C, which is 1 over 3 times 10 raised to power minus 6 times 150 times 150. Remember, it is V squared. Here I have V squared. Now, so that 3 here is 1. 3 in 150 here should be 15. 2 here is 1. 2 in 150 is 75. That's 75. So that E now will be the same thing as 50 times 75. That's the same thing as 3750 times 10 raised to power minus 6. I can easily write this as 3.75 times 10 raised to power minus 3 joules. Energy is measured in joules. Now, this is E, that is a very energy deposited in this circuit. To find the energy deposited across each of these, remember we said that our energy E is the same thing as 1 over 2 C V squared. Now there's a voltage across them, and because the combination is in parallel, if I put a voltmeter here to measure this voltage, the voltage across each of them will be the same thing. So the first thing is to find out voltage, and remember they have a combined capacitor. So if my C1 from our initial calculation, my C1, we got it to be 1 all over 3. This is my C1 here. We got it to be 1 all over 3 times 10 raised to the power minus 6. So if my C1 is equals to 1 over 3 times 10 raised to the power minus 6 farad, definitely my C2, which is 4 times the C1, will be the same thing as 4 times 1 over 3 times 10 raised to the power minus 6 farad. So that C2 is the same thing as 4 over 3 times 10 raised to the power minus 6 farad. Now that's for C2. Now we've gotten the value of C1 and we've gotten the value of C2. Next is to calculate the voltage to determine the energy across them. Now the voltage, to calculate the voltage, we must look for the combined resistor CT. CT, since they are in parallel, will be the same thing as C1 plus C2, which is equals to 1 all over 3 plus 4 over 3. That's the same thing as 5 over 3 times 10 raised to power minus 6 farad. Now with this, I can now begin to calculate the voltage across the whole circuit. My voltage V is the same thing as Q over C. Q over C. Q, remember we're given Q to be 50. That's 50 microcoulombs. That's the total voltage. Now we use that with the total capacitance. That will be 50 times 10 raised to power minus 6 over 5 over 3 times 10 raised to power minus 6. Minus 6 cancels minus 6. So 10 raised to power minus 6 cancels 10 raised to power minus 6. I'll be left with 50 over 5 over 3. This is the same thing as 30 volts. Now, so that my combined voltage or the voltage across each of them obviously is 30 volts, we have C1 to be 1 over 3 times 10 raised to the power minus 6, and we have C2 to be 4 over 3 times 10 raised to the power minus 6. With this, I can now calculate for each of the capacitance. I can calculate energy across C1, we'll tag that as E1, and we can calculate energy across E2. Let's create space for that. Now, to calculate for E1 will come from half times C1 times V squared, so that E1 is the same thing as half times 1 all over 3 times 10 raised to the power minus 6 times V squared. My V, remember, is 30 times 30. Now, 2 times 3 is 6. 6 in 30 here will be 5. So that my E1, here's E1, will be the same thing as 5 times 30, that's 150 times 10 raised to the power minus 6 joules. Now I can simplify that to be the same thing as 0.15 times 10 raised to the power minus 3 joules. So that my E2 will be the same thing as half times C2. C2 is 4 over 3 times V, here is half, this is 1 over 2, times V squared, that's 30 times 30 over 1 times 10 raised to the power minus 6. 2 and 3, that's 6. 6 here, that's 5. 4 times 5, that's 20. 20 times 30, that's 600 times 10 raised to the power minus 6, which is the same thing as, I can easily write this as 0.6 times 10 raised to the power minus 3 joules. Now, so we can now look at before and after. Before the recombination, I had a total energy of 3.75 joules. After the recombination, I have a total energy, my total energy after the recombination, I can write that as RT, which is equals to E1 plus E2. That's the same thing as 0.6 plus 0.15. Both of them is times 10 raised to the power minus 3. That's something as 0.75 times 10 raised to the power minus 3 joules. Now, so that my energy loss, we can now calculate our energy loss to be the same thing as E before minus ET. Will be the same thing as 3.75 times 10 raised to the power minus 3 minus 0.75 times 10 raised to the power minus 3 joules. So the energy loss is the same thing as 3 times 10 raised to the power minus 3 joules. Now, with this, I hope you understand how to work with energy in capacitors.